Actually, I caught my mistake. I'm using 12 volts where I shouldn't be using that. It's actually 15 volts, the voltage in each branch. So if I were saying it was 12, that was wrong. It's 15 in each branch. So yeah, 15 volts divided by 4 amperes. That's going to give us 3.75 ohms. So yeah, that gives us the right answer. We're good with the resistance. Now I'm gonna erase all of this, so if you want to take a look at the work done, just pause the video or go back. Okay, so now to get the EMF, we're gonna have to use some color coding. But before that, I know the current in this branch is 4 amperes. The current in that branch was also, what was it again? We have 15 volts. And yeah, these guys are in series, so that's 6 ohms. A is equal to IR. I'm just gonna find the current again. So voltage divided by resistance, that's 15 volts over 6 ohms. Basically, I'm trying to find the current again. What was it? Yeah, 2.5 amperes. Okay, that makes sense. Yeah. So the current in this branch was 2.5 amperes. The current in that branch is 4 amperes. Whoops. There we go. Now I'm going to combine these two resistors into one, and then I'm going to find the current in that one branch. So what I'm trying to say is I'll take the circuit I think you're getting the idea. And there's a voltmeter up there, whatever. What I'm really doing is this, combining these 3 ohm resistors into one. So I'm going to use the parallel rule, essentially, the inverse, taking the inverse of the resistance and for parallel resistors. So 1 over 3 plus 1 over 3 inverse. And that's going to give me the actual new resistance here. That is 1.5 ohms. Okay, awesome. So I know that the voltage across each branch, once again, to remind us, is 15 volts. I use Ohm's law again. Maybe I'll label this for you guys again. So that's 2.5 amperes. This was 4 amperes. I'm just going to assume that the current here is going this way. I'll call it I. And now the current here is 1. Wow, sorry, I have to calculate that still. IR. So IR 1.5 ohms. That's the resistance times I, which I have to find. So that's 15 volts. I is equal to 15 volts divided by 1.5 ohms. That gives me the new current. which is 10 amperes. Okay, I'm gonna erase all this because it gets too messy. So I know that the current here is 10 amperes. Awesome. So now basically I found the current and everything. The current flowing in this branch coming directly from the battery essentially is 10 amperes plus 4 amperes plus 2.5 amperes, and that gives us 14, 15, 16, 16.5 amperes. So yeah, that's 16.5 amperes. Now, we have the current, we need to find the EMF. Mm-hmm. 16.5 amperes, 16, that's a 1. Okay. Now, essentially, I'll just assume, and this technique actually works, that this entire battery with the resistor is like a non-ideal battery. So we have this formula for the terminal potential difference being the EMF minus IR. So basically I'm going from here, starting from the negative end of the battery, going through the positive end, hence the positive EMF, and then I'm going from high to low. Current is flowing out of this end, so I'm going from high potential to low potential, and we always do final minus initial. So whatever is, like, let's say we have a number here which is 5 and the number here which is 10. 5 minus 10, final minus initial, will give us a negative number, so hence the negative sign here. That was just an analogy, you don't have to worry about it too much. Now then, so I've assumed this is a non-ideal battery, and I know that the terminal potential difference is basically 15 volts, which is the voltage of this entire branch, this entire thing. So 15 volts is equal to EMF minus IR. In this case, I is 16.5 amperes, and we know our resistance, which is 1 ohms. Now we move then this entire thing to the other side to give us a positive value. So we have 15 volts plus 16.5 volts, which is equivalent to 31.5 volts, and that gives us our EMF right over here. So kind of to summarize everything, we wanted to find the resistance R. In order to do that, we need to know the voltage across that entire branch, keeping in mind that this is the only component in the branch that's going to experience a voltage. To find the voltage across an entire branch anywhere, we would have to use what they've given us, which is the 5 volt value here for this resistor, to find the current across this entire branch, and then we use that current to help us find the voltage of this resistor, and then we add the voltages of these two resistors to actually give us the voltage across a single entire branch, which was 15 volts. After having done that, we knew the value of the current in this branch, which is 4 amperes, and we know that the voltage would be 15 volts. So we would just rearrange and find the resistance using Ohm's law. V is equal to IR. So then we would find R. Then we would take a pause and realize, okay, yeah, now we have to go for the EMF. We know the current in these two branches, which is awesome. What I did here is just to make the problem a little easier. I would combine these two branches. Again, they're in parallel. Then once I combine them, I'd basically calculate the equivalent resistance. Once I would have the equivalent resistance, and I already know that the voltage across a single branch is 15 volts, I would rearrange for the current across this combined branch. That current was 10 amperes. This guy was 4, and I think this guy was 2.5 amperes. And then so yeah, essentially I have all the currents. So then I basically added them all up, and that would give me the current that's actually leaving the battery here. Once I had that, I knew that the terminal potential difference was 15 volts, the voltage across each branch. And I already know the current in the branch, and I know the resistance of the internal resistance, sorry, that's how we would say it. So then I would just sort of rearrange. I know these values, I know this, so I would just bring this here, add them up, and then I would get the EMF. So that was pretty much like a summary of the problem. I hope this helped, and again, I know the video was kind of long, so it would be a good idea to watch these on 2 times speed, and then, reduce the speed whenever you feel like you didn't understand something. Take care.